Alright, so I think I'm recording. We're taking a look at skill packet 3, which is relations and functions. And in one of these subskills, we are looking at how to build new functions. If you're given a function f and you're given some function g, they could be different letters. You're given two functions. Can you use those two functions to create a new function? Well, yeah, you can. If you multiply or divide or add or subtract, you'll create a new function. And of course, whenever we have a function, a new function, we are interested in the domain of that function. So we're going to have an upcoming quiz that asks us to create a new function through multiplication and division of these two functions, and we want to find their domains. So we know, or at least I hope that we know, that if you're given a function f and you're given a function g, that you can find the domain of a new function f times g by intersecting the domains of f and the domain of g. Intersection is we translate it with the word and. When it's a U, it's a union, and it's translated as the word or. So to get our answer, we use this idea of the intersection of two sets. Now, when we have division, it might be the same answer as multiplication. However, it could be different. And the reason it could be different is because we'll have a function in a denominator, and anytime you have something in the denominator, it can't equal 0. If you have a variable in the denominator that causes that denominator to be 0, you have to throw that value of x out of the domain. So that's the idea. We use our answer from A to help build our answers for B and C, if I call it A, B, and C, for the domain for the division problem. So let's take a look at our last problem here. I've made videos on the previous two problems. Here I've got a function f and I've got a function g, and I want to create a new function where I multiply f and g together, but I don't want to take the time to figure out what a new expression is. I don't want to multiply these two fractions together and reduce them to lowest terms and stuff and use that. I want to just jump right in and find the domain of this new function by finding the domain of f and finding the domain of g and intersecting them together. So in order to find the domain of f, I need to prevent this denominator from equaling 0. Well, that's not in factored form, so it's a little bit hard for me to see what value of x would cause this to be 0. But if I write this in factored form, if I come up with two numbers that when multiplied together give me 6, but yet when added give me 5, which 2 and 3 do that trick, then now in factored form I can see what I need to avoid. I do not want this to equal 0. So what values of x would cause it to equal 0? Well, negative 2 is going to give me problems, and negative 3 is going to give me problems. I want to prevent that from being 0, so therefore I want to prevent any numbers, negative 2 and negative 3, that are in the set of input that are in the domain from ever being inputted into this function, because they cause division by 0 and there won't be an output. So I'm going to throw those two values out of the domain of f. Alright, now the domain of g is a lot easier because I don't have to factor it. I can just look at this by inspection and I can see, well, if x were allowed to equal 0, then you'd have negative 1 divided by 0, and that's undefined. I can't let 0 be in the domain of g. So I need to intersect these two sets together. These have to be true at the same time. X cannot be negative 2, and it cannot be negative 3, and it cannot be 0. All of those at the same time. So you're getting to a point now where you probably don't have to draw the picture to intersect these two sets, but I'm going to anyway just in case somebody still needs it. So for the domain of f, I'm going to throw out a negative 3. I'm going to throw out a negative 2. And everything else I'm keeping in the domain, because those were the only two values that caused any problems that caused division by 0. So now I'm going to look at the domain of g, draw a picture for it, and it can't be 0. I'm going to put 0 over here, and I'm going to shade in everything except 0. 0 was the only thing that caused me trouble when I looked at the function g, it was if you input 0 into the function, you divide by 0. We don't want to do that. So if I'm intersecting these two sets, I need, let's draw a picture. I need for these to be true at the same time. Negative 3 is not in both, and therefore it will not be in my answer. You have to be in this set and you have to be in this set in order to be in my answer of the intersection. Negative 2 is not in both, and 0 is not in both. But if you look at these graphs, everything else is shaded to the left at negative 3 in both graphs, and to the right, and here in the middle, and here, because here's negative 3 that's shaded, and here's negative 2 that's shaded in that graph. So this is my domain, the picture of my domain for f over g, and I need to just describe that using interval notation, because I can't describe it really any other way. I can't list all the values. So I'm going to do it with interval notation. The domain of f over g is equal to, well, if you're in this interval that's on the far left, you exclude negative 3, or if you're in the middle here between negative 3 and negative 2, or if you're in this middle portion between negative 2 and 0, and if you're bigger than 0. So there's my domain for f divided by g. Alright, so let me now find the domain of g divided by f. So I keep a huge part of my work, the domain of f, the domain of g. I can erase this g. I want to now prevent f from being 0, because if I'm trying to find the domain of g over f, I now have to be concerned that the f of x could equal 0. I need to prevent that from happening. So I've got, you know what, I didn't do f over g, did I? I just did f and g. Oops, sorry. Here, let's do f over g first. I'm listening to the Bob and Tom show at the same time I'm doing this, so I'm sorry I wasn't paying much of attention. Mike Toomey was on. If you have a chance to YouTube Mike Toomey and on the Greyhound bus, I think you'll get a kick out of it. Alright, so this g of x is not equal to 0, and because it's in a denominator. Well, what is g? It's x squared minus 1 over x. If I have a fraction, and if I allow that fraction, if I'm interested in this solution, when this fraction reduces to 0, it's not because of the denominator. The denominator can never be 0. It's because of this numerator. So I need to solve this equation, and it has two solutions, negative 1 and positive 1. If you input negative 1 into g, you'll get 0. If you input positive 1 into g, you'll get 0. Alright, so I need to prevent that from happening. So I need to come over here. Negative 1 is between negative 2 and 0, and positive 1 is to the right of 0. I want to throw out these two values. Alright, so now the domain of f over g. Negative 3 is not included in all three sets, because you have to be in all three to be in the intersection and in this domain of f over g. So I'm going to throw out negative 3. I'm going to throw out negative 2. I'm going to throw out negative 1, and negative 2 is to the left of negative 1. Negative 3 was to... pay attention to what I'm doing. It's shaded between negative 3 and negative 2. And then it's shaded between negative 2 and negative 1. And then it's shaded between negative 1 and positive 1. and then 1 to infinity. So we had to throw out 4 values, -3, -2, -1, and +1 for the domain of f over g. All right. Now, finally, g over f. So let's get rid of this other work. And g over f, hey, we're afraid of f being equal to 0. It's okay for g to be 0 now because g's in the numerator. F is in the denominator, and I can't divide by 0. So what's f? F is x minus 1 over this x squared plus 5x plus 6. Well, when does this fraction reduce to 0? Well, when does any fraction reduce to 0? When the numerator equals 0. And if I set this numerator equal to 0, 1 minus 1 is 0, I have to avoid the number 1. All right, see, last time I avoided -1 and +1. Well, this time I'm only avoiding 1. So when I come over to draw the values that are acceptable for f that don't cause division by 0, I get this. Remember, you have to be in all 3 sets to be in the intersection. So is -3 shaded in all sets? Well, no. Is -2 shaded in all 3 sets? No. Why did I said -2? I think I did. And +1. So everything else is shaded on this number line. It's only these 3 values that we're throwing out of the domain. So the domain of g over f is all real numbers excluding the number -3, excluding the number -2, excluding the number +1. So there's my domain for g over f, and I hope that helps. And sorry about not paying attention as I was listening to the radio while I'm making this. You can't hear it because you can only hear what's being played, what the mic is picking up, and internally, I guess, I'm able to listen to the radio and listen to Bob and Tom while I'm making these. So sorry about laughing through these. All right, hey, I'll talk to you later. Bye.